So let's go through what Delta Math Coins is a level 4 type of problem. So this is a harder sort of radical equation because there is two square roots, right? There's one on each side, and there are coefficients with the x's on the inside. So it's probably going to end up being a quadratic equation that has a coefficient, a leading term, right? It's going to have a number other than 1 in front of the x squared term. So I already have a square root, right? I have this square root isolated by itself on the right side. So I'm just going to go ahead and square both sides, right? Because if I do that, right, that square root cancels out, so I get 6x plus 7. I go ahead and change the background of this paper so it's not so distracting, right? And then I'm going to write this out twice to show that I'm squaring it. So I'm going to go ahead and FOIL, right? You can think about it just distributing. So if I multiply the square root of 3x times the square root of 3x, it's the same square root twice. So the square root symbol is going to cancel out, right? The square root of 3x times negative 2 is negative 2 square root of 3x. We have another negative 2 square root of 3x. Oops, almost forgot the x there. And then we have negative 2 times negative 2 is positive 4. Right, and that's still just going to equal 6x plus 7. So then I'm going to collect my like terms on the left. So I get 3x minus 4 square root of 3x plus 4 equals 6x plus 7. So I have another square root now. So I want to now get this square root by itself, or as close to itself as possible, so that way we can get rid of it. So I am going to subtract 3x here, and from its like term over here, so that's going to give me 3x. And then I'll subtract 4 here, it'll give me plus 3. Right, and that's going to equal negative 4 square root of 3x. Okay, so now I'm going to square both sides as is, because I don't want to deal with fractions. Right, so over here, I'm going to do negative 4 squared, right? And then the square root of 3x all squared is just going to give me 3x. And then I'm going to write this out twice. Okay, so negative 4 squared is 16. 16 times 3x is going to give me 48x. And now if I FOIL on my other side, right, 3x times 3x is 9x squared. 3x times 3, 9x. 3 times 3x, another 9x. And then 3 times 3, 9. Okay, right, so I have 48x equals 9x squared plus 18x plus 9. Let's go ahead and make this equal to 0 by subtracting 48x from both sides. So 18 minus 48 is going to give me minus 30x. So I'm going to get 0 equals 9x squared minus 30x plus 9. And then the smartest way to do this when we're factoring is to take out any GCFs if we can, right? So I have a GCF of 3. So I'm going to divide everything, including the 0, by 3. So now I get 0 is equal to 3x squared minus 10x plus 3. And that's a lot easier to factor. So to factor, I'm going to use the big X. So I want to multiply to 3 times 3, which is 9, and add to my middle term of negative 10. So the numbers that are going to do that for me are negative 9 and negative 1. So because I have this 3x squared here, I can't just break it down into parentheses sets right away. So what I have to do first is break that negative 10x up using the two numbers we just came up with. So negative 9x minus 1x still gives me negative 10x. And then I'm just going to bring down the rest of the problem. So then I have 4 terms, so I'm going to cut it in half to do factoring by grouping. So here I can take 3x as my GCF out of the first 2 terms. So I'm going to get 3x times x minus 3. And then if I look at the second group, I'm going to take a -1 out of both as their GCF. And I'm also going to be left with x minus 3. And we still have that equals 0 in the front. So if I rearrange my groups, I'm going to get 0 equals x minus 3 times 3x minus 1. Right, so I'm going to go ahead and set these groups equal to 0. I'll do this one first. So if I add 1, I'm going to get 3x equals 1, and then divide by 3, I get x is 1/3. And then over here, right, x minus 3 equals 0, x can equal 3. So now, right, zoom back out, right, look at all this algebra we've done. Right, so we still have to check our answers. So I'm going to go ahead and check x equaling 3 first, because that seems easier. So I'm just going to go back up here so I can actually see the problem. So if I plug in 3, I get the square root of 3 times 3 minus 2 equals the square root of 6 times 3 minus 7, right? Just replacing the x's with 3. So I get the square root of 9 minus 2 equals square root of 18 minus 7. Oh, plus 7. Whoops, that's a typo. I was like, why is this really weird? So square root of 9 is 3. 3 minus 2 equals 18 plus 7 is 25. So 3 minus 2 is 1, and the square root of 5 is 5. So 1 does not equal 5. So that tells us that x equaling 3, right, this is extraneous. So then I have to check my x equaling 1/3. So, and we'll go down here. There's more room down here. So we got check x equaling 1/3. So I'm going to get 3x is going to be 3 times 1/3. That's still in a square root. Minus 2 equals square root of 6 times 1/3 plus 7. Okay, so 3 times 1/3 is the same as 3 divided by 3, so that's 1. So I get the square root of 1 minus 2 equals 6 times 1/3, right? 1/3 of 6. 6 divided by 3 is 2, so I get 2 plus 7 in here. Square root of 1 is 1. 2 plus 7 is 9. So I get 1 minus 2 equals 3. Well, that's also not true. So this is also extraneous, which means overall we have no solution here.